used defined in Java and trying to follow the rules of the Java, trying to follow the rules and definitions of Java so that your Java program will get executed as per your requirement, as per your business logic. That's nice. So the next question comes into your mind is, what if something goes wrong, right? In simple generic way, think like this. In US we have a rules, right? What rules we have while driving? First you need to take the driving test and you need to clear the driving test saying that you know the rules and regulations in terms of terminology, right? If you see red, what you need to do. If you see yellow, what you need to do. If you see red, green, what you need to do. Those are different definitions that US has been kept in order to drive a car in the road. Then next what they will do, you need to do the driving by keeping next to the instructor so that instructor evaluate whether you are eligible to drive the car on the road irrespective of someone monitoring or not. If both works fine, then they will give you a license. And after getting license as well, if you do something wrong, you will get the points. Cop will give you the points, tickets, and based on severity of the problem, you will need to attend the court or service, social service, all these things. These are all the exceptions that has been defined. Okay, in the day-to-day driver, and everybody is driving like going to office, coming to home, going to groceries, coming to home, living happily. This is the regular standard definitions, whatever rules that has been defined in the driving book. If you follow, right? What if something went wrong because of you by looking at your phone, you did something wrong, or someone behind by looking at phone, they troubled you by hitting your car, or you troubled someone by hitting the car. Then all the exception scenarios comes, right? You need to have an insurance, and you need to have a cop, you need to get the ticket, you need to get the proofs, and all this process. In Java also, what if something went wrong, right? If when you are writing your program, what if you try to write not following the standards of Java? One way to is giving the compile time errors, and another way is giving the runtime errors where you cannot capture, like compile time errors are like passing the exam, and driving nice when the instructor is next to you. Those are all compile time errors kind of thing. You honored them and you got that license. Now what if you did an accident, right? Later you, because of you drunk and drive or whatever the reason, you went and you break the rules, right? This is nothing but runtime exceptions. Compile time errors, compile time exceptions, runtime errors, runtime exceptions. So there are in Java also, these kind of violations has been divided into two parts. One is exception part, another one is error part. Okay, so let's see one at a time. If we do the programs, that would be the better way to. So let's write a simple program. Okay, error scenario. I'll write two methods. Okay, static void method. method 2. Okay, I will say I am in method 1. I am in method 2. Okay, so what I will do, I'll just call method 1 method 2. Let's run this program. Oh, again happened this one. Seriously, dear, I hate this. I don't have time, and again this problem. Task. Yeah, it's mostly a memory problem actually. Give me a second, guys. Damn it. Looks like it didn't got saved. It's okay because I forcefully exited, right? Oh, it came. Okay, nice. Okay, so now if I run this program, I'm really sorry, guys. I'm in method 1, I'm method 2 because you called two methods. So I'm going to do one small change. Okay, I'll call here method 2. Okay, now I'll run the program. It worked fine. First it called method 2, it printed, then method 1, then here it is calling method 2 and method 2 exit. Nice. Now I'll come here, I'll call method 1. Done, you got something. it didn't display what you expected. What is the exception? You got an error, not exception. You got an error. What it is saying? Stack overflow error. Java.lang.stack overflow error. If you remember, I explained you guys how memory works, right? Sometime back, the basic memory structure. In your memory, one part will goes for heap and another part goes for stack. In stack, what will happen? Methods will be loaded into stack, right? One at a time, right? So method 1 loaded. Inside method 1, what is there? Method 2 is there. Method 2 will be loaded. Inside method 2, what will be there? Method 1 is there. Inside method 1, method 2. Inside method 2, method 1. So a cyclic dependency has been created here. Method 1 calling method 2, method 2 calling method 1. It's keep executing. It never stops. The program never stops, never turned off. It's just keep loading and the stack will get full because you are not taking out any of the methods, right? Because it's just keep piling up. Your stack is getting piled up. So what will happen when it goes, when it fully occupies the stack memory, it will give, I cannot do anything because something wrong with your program. So I'm throwing you an error, not an exception. I'm throwing you an error saying that I cannot run this program, something wrong with your program, go and fix it. Okay? So errors are something which you cannot rectify. Errors are something which you cannot handle while running the program itself, which you cannot handle while running the program itself. What you need to do, you need to go back and correct your program. What is the correction you need to do? Either you need to remove this guy or either you need to remove this guy. Then only this program will get fixed. Right? These are all called errors. These are all called errors which you cannot be fixed as part of the program. Only way to fix this kind of things is you need to go back and correct that program. So whenever error happens, so one of such error is stack overflow error. Okay, there are different errors. You know, if the heap is overwrites, if these guys keep on filling with objects, then it will get out of memory error. Okay, there are those kind of errors, different type of errors. Java already has been defined. Java is smart enough to identify what kind of error is happening through program. Okay, we'll go deeper on that. So this is kind of exception, error. You guys understand? So next, let's write another program. I'll say scanner scan equal to new scanner. Okay, system dot in. I'll take input from the system. Enter the value. Then int a equal to scan dot next int b equal to scan dot next int. Okay, I'll ask I'll take two values, I'll do some division. Okay, now I will do int c equal to a by b. Okay, so result c is there anything that we can try exception to simulate, right? Yeah, I can say program finished. Okay, so now let's run this program. Enter a value, I'll say 10, b value 5, result is true, program finished. Nice. Let's run it again. Enter a value 10, b value 0. You will got what? An arithmetic exception you got. Some exception you got. Right? So as whenever you pass b as 0, whenever you pass b as 0, then it goes into the infinite. So that is the reason it throws some exception here, not error, some exception. With exception, you can correct it by providing the inputs, proper inputs, you can handle the exceptions. Okay, now as long as if I'm passing proper values, I'm able to handle the exception. But error is not like that. How to handle it, I'll explain the exception, but what I'm trying to say, error you cannot handle it. Error, you cannot handle it. So having said that, let's come back to the concept. Basically, we have two things. Java.lang. Throw one thing it is, and so there are bunch of exceptions that Java already defined for you. There are bunch of exceptions Java already defined for you. Okay, if you try to do these divisions improper, it can identify to arithmetic exceptions. If you try to connect to the database and if you get some errors, it identified as SQL exceptions. If you try to connect to the network errors, it's IO exception. If you try to connect, like try to do some bad operations on the string, it will say bad string operation exception. Or if you try to parse wrong data, it will send you parsing exception. So there are bunch of built-in exceptions already defined in Java, right? So basically, like I said, exceptions world is something like this. Who is the superclass in entire Java? Object class, right? Java.lang.object. This is the superclass on all the objects. And one of the class, that built-in class that extends is java.lang.throwable. What is that? Throwable. This is the class that has been extended by Java class object class. Okay, from here the exception world begins for Java, and then this has been segregated into two parts. One is java.lang.error class, okay, and another one is java dot, here we have it, where did it go? My document, I'm just looking for my document. We have a diagram, no need to struggle to write the diagram. So this is the family. So object class, throwable class, then exceptions and errors. These two are interfaces which will extend throwable class, and then there are different type of classes: runtime exception, class not found exception, illegal argument exception. So exceptions are divided into two parts: errors and thread death. So this is errors world is simple, but exceptions has been divided into further. Compile time exceptions, this is the highlighted for class not found is one of the compile time exception, okay. And then runtime exception. Runtime exceptions are happens at while you are running your program. There are bunch of runtime exceptions, okay. So here if you come down in this family, try to understand. Java.throwable class, this is the class is accessed by Java object, right? So, and java.lang.exception is this is also exception class, which is extending throwable class, and then exception class further has been divided. All these are compile time exceptions except one exception will be there, runtime exception. Apart from this, all these exceptions that has been mentioned here are compile time exceptions. And when you click on runtime exception, you will see these are all different type of runtime exceptions that we have. These are all the different type of runtime exceptions that we have, which will happen at runtime. Apart from these guys, whatever happened here except runtime exception, except the highlighted runtime exception class, remaining all compile time exceptions. Okay, so exceptions has been further divided into compile time exceptions, runtime exceptions. Runtime exceptions has its own set of exceptions, and compile time exceptions are it has its own set of exceptions. Okay, so the error we are seeing here, arithmetic operation, is it compile time exception or runtime exception? It is a runtime exception. Let's see where it is actually. You don't find here. It's a combination of all compile exception and parent exception of runtime exception. And if you search here same one, you will see here. So arithmetic operation, array index out of bound exception, array store exception, class cast exception. These are all cannot be determined at compile time. If you look at here, can you able to say this will give you an error? As long as user pass the proper values, you don't get an exception, right? Only if user passes the wrong b value, then only you will get an exception. When do you know user will pass the wrong values or correct values? Only at runtime. So you get to know whether this exception happens or not in runtime only. right? But instead of that, there are some compile time exceptions which you can expect, like, they will happen at compile time itself. Okay, let's see what are those. Can we see? You understand? I'll tell you. So that is one piece. Second piece is what exactly happens. What exactly happens when you write code? What exactly happens when you try to write the code? First and foremost thing is your code will be loaded into the memory, right? Which means your plain whatever the text that you written will be loaded into memory, and then whatever the logic that you have, it started loading into the JVM and started executing accordingly from main method, right? So whatever you wrote inside this method, whatever the, not only here, whatever you wrote, the statements, Java statements, they are all going to be monitored by JVM. And if an error or exception happens, then it identifies corresponding exception class, corresponding built-in exception class, and then it creates an object for us and it throws the object for us. It catches the object and terminates the program, and JVM displays that info into the info of that object. That's what happened. So when something went wrong, so it's keep on monitoring all the statements, right? Okay, when something went wrong on a particular statement, it identifies what you what is the possible reason for failure. Once it identifies the possible reason for failure, it creates that object. It creates arithmetic object. You are nowhere created that object right here, but it creates this arithmetic exception object, and then it sets this value by 0. So by 0, this is what you are doing. That is something wrong at line 14. So this is the line 14. So when you click on this line, when you click on the exact error, it will highlight that and C equal to A by B. So that is the line which caused the error. So you don't see the result value or program finished here because the program terminated there. It doesn't continue to execute the program, right? So basically, you want to handle this program such a way, if something goes wrong, ask the user to properly input the value and then continue the program. That is the sequence that you are expecting. How can you do that? How can you do that? Using these 5 keywords: try, catch, finally, throw, throws. These are the 5 keywords among the 50, 49 keywords that we have. These are the 5 keywords that we are using in exceptions in order to handle the exceptions. Okay, in order to handle the exceptions, we use these 5 keywords to handle it. How we are gonna do? So basically, it's simple. It says, if you started writing code, okay, you may expect something goes wrong in this part. Okay, keep that part in try block. Keep that keep that piece of code in try block, and then if something goes wrong, convey to JVM, convey to Java what kind of problem that you are encountering through catch block. You may be expecting arithmetic exception, you may be expecting array index out of bound exception, you may be expecting SQL exception. So convey that through catch block, and there you do whatever you want. You handle that error. Like, instead of throwing this error, by looking at this user may confuse what wrong I did, because user doesn't look at the program. Always user enters the inputs and he expects some result. He doesn't understand this. Convey the user what he did wrong. You need to convey, instead of showing this error, you need to convey to the user, hey, B value should not be 0. You need to enter B proper value, then only I can do the division for you. That kind of message you want to convey, right? So do that in your catch block and then continue the program without terminating. So in this case, as and when something happened here, these two lines doesn't execute it. These two lines doesn't execute it because the program terminated. Instead of terminating, you want to continue. You want to convey the user this is happened and continue the program. How can you do that? Like I mentioned, using try, catch, finally, throw keywords, and try block, where you need to keep all the statements, all the Java statements that you expect some errors, some exceptions, not errors, some exceptions, and catch block, where you define all kind of exceptions that you are going to expect, and finally block. Finally block is something irrespective of what happens here and here, you want to execute these statements. So finally block can be used to execute certain statements irrespective of something went wrong, like now this program doesn't execute properly, so you want to execute this line no matter what happens here. Then keep this statement in finally block. Then if something goes wrong also, that block will be executed. Okay, these three together, try, catch, finally. Let's see how it goes. Okay, by doing the program we can understand easily. Same program we will convert into using the try, catch block, all the statements. Okay. What we can do here, scanner scan, equal to scanner. Can we try something else? Value. And so you expect this statement something goes wrong, right? So let's keep these statements in try block. How do you keep in try block? Just try block and corresponding, when you try, open the traces and close it. So move this piece of code into try block. Okay, then immediately you need to have a catch. You should not, Java doesn't allow, like, write something here. Something like this. It doesn't allow to enter. So basically, always immediately catch should be there or finally should be there. We'll see what and all allowed and what and not allowed. That is like definitions. So okay, here you will say, instead of throwing an exception, I'll say, hey, looks like inputs are wrong, please try again. And catch, you need to convey what kind of exception, right? So for now you're globally, you don't know what kind of exception, so you're globally defining catch exception E. And here you just mentioning program finished. So all we did is we moved all our statements into try block and immediately a catch block with as in argument as exception, as we don't know for now. Like, you can write what kind of exception as well, and then you convey the user, hey, looks like your inputs are wrong, please try again, and program finished. Let's run this. Enter 1, 10, 2 works fine. Run again. 10, 0. So this time you didn't get that, like, weird red color arithmetic exception or something. So now same thing, right? When in your Bank of America, when you're trying in Bank of America, whatever the bank, that when you're trying to transfer, there will be amount section, there will be user section, there will be IFSC section. In place of IFSC, you try to enter amount. In place of amount, you try to enter IFSC code. When you try to submit, it will say, it doesn't show you weird error. It will say, hey, your IFSC code looks like wrong. The amount you enter is invalid. Please check, right? So you get a chance now to convey. You catch that exception, you convert whatever the user readable format and give it to them. Okay. Second important thing that you observed in earlier program, as and when something goes wrong, these statements never executed. These statements never executed, right? But in this case, if something goes wrong here, it goes here immediately. It doesn't execute the statement in that block. It goes immediately. After that, it will continue to execute this program. It will continue the program. Okay. So let's say this is how you can write try catch blocks together. Okay. So what are the rules and regulations? What are the rules and regulations for writing try and catch blocks, right? So these are the rules. Only one try catch finally. So only if you want to write catch, you need to write like this. One approach is try and then catch. Try catch. Another one is try catch catch. You can write as many catches as you want. We will see another example. Okay. Another one is try catch finally. This is allowed. And another approach is try catch finally also allowed. Or else just try finally is allowed, but try finally catch is not allowed. So these are the structure, like, these are the whatever the statements that you mentioned in the try will be monitored, and if something goes wrong, catch will be catch. And if some statements that you want to execute irrespective of what happens inside, then those statement goes to finally block, right? So let's say, and there are rules. Let's see. Okay, try block is used to place the statements needed to be monitored in case of abnormal behavior. That's what we kept. This we kind of suspected some of the inputs can be wrong, so I am expecting abnormal behavior in these statements, so I'm keeping them in try block. Catch block is used to catch the exception raised by the try block. So when this line goes wrong, this catch block responsibility to talk to the JVM and make sure to identify what kind of problem that has been encountered here, and send those problem into this catch block. So if something goes wrong here, if something goes wrong here, it will go here. Otherwise, it doesn't enter into the catch block. If something abnormal happens in your try block, catch will happen. Otherwise, it doesn't happen. Otherwise, it doesn't execute at all. Okay. And so what they are saying, so these are the rules. Catch should followed by try immediately. Other statements are not allowed between try and catch. For one catch, we can write more than one catch block. So now we wrote one catch block, right? I can write another catch block saying here. Okay, but when you are writing these exceptions, you need to follow some rules. I'll tell you. In case of more than one catch block, order of exceptions must be subclass to superclass. Subclass to superclass. So if you come back here, who is the superclass in this block? Object is a superclass. Next is throwable. Next is exception. Next is runtime exception. Another one is class temp. So between runtime exception and illegal argument exception, who is the parent? Runtime exception is parent. Illegal argument is subclass. Between exception and runtime exception, who is the parent? Who is the child? Exception is the parent. Runtime exception becomes child. Between runtime exception and index out of bound exception, who is the parent, who is child? Index out of bound exception is child, runtime exception is the parent, right? So what the rule is, when you are writing, in case of writing more than one catch block, order of exception should be subclass to superclass. So when you write exceptions, you can write first catch block is subclass and then you can write superclass. So I'll tell, like, you know, arithmetic exception. Sorry, this one goes above. So this is now, if you observe, first superclass, subclass, and then superclass, right? If you try to keep this guy below, try to understand, okay? If you try to keep this guy below, it gives an error. It never reaches. What happens, right? Try to imagine, right? It's not easy. What happens is, if something goes wrong here, immediately it goes to the first catch block. So first catch block, if you keep this guy above, even though it's an arithmetic exception, you are trying to handle it through parent class, so it satisfies and it goes here. So if you keep this block, if you keep these statements like this, what happens is this block never encounters, because exception is something which can handle the arithmetic exception as well. That is the reason first you convey what kind of sub exceptions, subclass exceptions that you are expecting. Then let's say now I wrote like this, right? Simple, okay? If arithmetic exception happens here, then it goes here. If something else happens here, it goes here. Let me show you something else, okay? I'll define int of an array x and new int of 1. Okay, size is 1, right? So all I can do is x of 0 equal to 20, and I'm trying to do x of 1 equal to 32. Okay, I said the size is 1, but I am trying to enter two values. Let's see what will happen. Enter a value, I enter 10, I enter proper value. Okay, result is 0. Hey, looks like so inputs are wrong, please try again. Okay, I need to correct this same statement. You don't differentiate, right? Hey, looks like arithmetic. New exception. I just want to display that exception so that you can understand. See, the arithmetic exception didn't occur, but something else have new exception. So result 5 is displayed. So this operation went fine and the result is displayed. Now you try to do some operation related to index. So you got array index out of bound exception. Array index out of bound exception. And as this array index of bound is not satisfying arithmetic exception, then it goes to the exception. Array index out of bound exception is, if you look at here, runtime exception. It's not there. And if you go here, array index let's copy it. What happened? Oh, okay. First is index and students. That is subclass of subclass. Index out of bound exception. In that it has array index out of bound exception. The structure is Java objects, throwable exception, runtime exception, index out of bound exception. In that index out of bound exception, array index out of bound exception. That is the exception it throws. In order to handle, as array index out of bound exception is part of the exception. So when you keep this guy, it satisfies here parent class, so it displays, it enters here. Understood? So let's say now you suspected, like, because of this new line of code, you suspected you will get array index of bound exception. What you can do, you can write another exception, array index out of bound exception, and this exception. So when this failure happens, because of B is 0, arithmetic operations happen. When because of this index happens, you will get array index out of bound exception. Beyond this, if you wrote something else right here, some other code you wrote, right? Because of that new code, if something goes wrong, and then it goes to exception class. The exception class is a generalized exception class of the parent of all kind of exceptions. Okay. Yeah, that's it for today. Tomorrow we'll continue on exceptions, and I will show you how to write throws, and how to write user defined exceptions, and I'll go through 3 to 4 examples again. One is for we'll see how null pointer exception occurs and how do you determine runtime exceptions, how do you distinguish between runtime exceptions and compile time exceptions, and which one's called checked exceptions, which one doesn't called unchecked exceptions. So these and all scenarios we'll go through tomorrow and wrap it up exceptions by tomorrow. Okay, I'll record it.